Our objectives are to be able to solve problems involving symmetry and transformation. We'll be able to determine whether a figure is symmetric with respect to a line or a point, and be able to identify tessellations. A figure has line symmetry if it can be cut into two identical pieces by a line. A figure can have more than one line of symmetry or no lines of symmetry. Take a look at these pictures and see how many lines of symmetry do you think they have. Well, this looks like an isosceles triangle. Therefore, I should be able to cut it straight down the middle vertically with that vertical line, and therefore the left half looks congruent to the right half. Therefore, this has one line of symmetry. Can I draw a line going this way from this vertex into this side? I can't, because this side is not congruent to this side. Let's undo that. How about the next one? Well, this triangle looks like it is equilateral, which means all three sides are congruent. Therefore, I can do that vertical line going down the center. That's one line of symmetry, so this half is congruent to this half. But I can also do this line and get this half congruent to this half, or this line and get this half congruent to this half. So this figure has three lines of symmetry. The last one looks like a scalene triangle, where none of the sides are congruent. So this one has none. There are no lines of symmetry for a scalene triangle. How about point symmetry? Well, a figure has point symmetry when the pre-image and image match after a rotation of 180 degrees. Remember, a 180 degrees means flipping it completely upside down. So it matches after this type of rotation through a point in the center. Ask yourself, does it look the exact same upside down? Well, let's check out these and see if they have point symmetry. So for the first figure, keep an eye on what the top part of the figure is. And I'm going to rotate this figure first 90 degrees and then 180 degrees, and now it's completely upside down. Does it look the exact same as when it started? Well, let me move this over and you can see, yep, it does look exactly the same as when it started. So this figure does have point symmetry. How about this playing card? Do playing cards have point symmetry? Well, I'm going to rotate it completely upside down 180 degrees. Does it look the same as when we started? Well, let's move this out of the way and check it out. Yes, playing cards have point symmetry. Which letters of the alphabet have point symmetry? Does an H? Does a T? Well, let's do our test. Can I rotate it completely upside down? For an H? Yes, I can. An H has point symmetry. How about for a T? If I turn it completely upside down, 180-degree rotation, it does not have point symmetry. So a T does not have point symmetry, but the H does. There are lots of other figures out there that have point symmetry. Can you identify some of them?